Hi guys, in this video we're going to be doing factoring by grouping. We've kind of already sort of started talking about it, but we're going to go more in depth. So in this case we have a polynomial that has 4 terms, and so we're going to be using the grouping method to solve this. So let's go ahead and take a look. We need to remember how to find the greatest common factor, and to do that, so let's just do this real quick example. From 5k squared and 10k, we see that we can take out 5, and we can also take out a k. Why? Well, because 5k times k would give me k squared, and 5k times 2 would give me 10k. So the greatest common factor of this is 5k. That should be review. So let's go ahead and do example 1. In example 1, we have 4d cubed plus 8d squared minus 5d minus 10. So what we're going to do is we're going to make groups. The first thing I'm going to group is going to be these, and then I'm going to group these. So we're grouping them as binomials, and then trying to see if they have common factors. So right away I'm going to see if I can factor anything out from here. So I have both of these are divisible by 4, so I'm going to take that out. And both of these I could take out a d squared. That's the biggest I could take out. So I factored the first part. Now let's do the second part. In this group, right away I see that I could take out or divide by a -5 from both. So I could take that out. And this 10 doesn't have a variable, so that's about as much as I can go. So now that I've factored, what my goal here is to get things in parentheses that are the same. Just like when we were factoring in that other video where we had just x squared plus a squared plus bx plus c. In that form, once we found the two factors and we wrote it, and then we grouped and we took out the common term, the greatest common factor from both, we wanted to have something left that was the same for both. So here we have d plus 2, which is the same. So now what I can take out is I can take out this d plus 2. My factor is d plus 2. What is left over? Well, I'm left over with 4d squared and minus 5. So I have 4d squared minus 5. And this is my completely factored form. Now remember, guys, there's no reason for you to get this wrong. If you're taking a test, go ahead and go back and read and check your work. D times 4d squared, d times -5, 2 times 4d, 2 times -5. Test it out. See if you actually do end up with this big, long polynomial. Okay, let's go ahead and take a look at example 2. In example 2, we're doing the same kind of thing. So right away we see, okay, I'm going to go ahead and group these two, and then I'm going to go ahead and group these two. So right away I see here, I can see that I can take out 2. I can take out an s squared also. So what am I left with? I'm left with s and then a minus 3. Now from here I see that I can take out, they're both 9 and -6 are both divisible by 3. So I'm going to go ahead and put positive 3. And so I'm left with, but if you notice, since I wanted to make these to be the same, I'm actually going to take out a negative. Why? Because if I don't take out a negative, these are not going to end up being the same. So I'm actually going to take out a -3, divide both of these by -3. Because if I do that, then I will be left with a 2s inside. Remember, our goal is to get two things in the parentheses that are exactly the same, so I can factor those out. So that's why we chose to take out a -3. So we were left with 2s plus 9. Okay, so from there, both of these are factors. They're the same, so I could take them out. So I would have 2s minus 3, and then what's left over? Well, I'm left with 2s squared minus 3, so I write that here, 2s minus 3. And now I am completely done. Again, if I wanted to, I could go ahead and actually distribute again, go backwards, and see if I got the original answer. Okay, and I believe we have one more. Okay, in this one we're doing, same thing, we're factoring out. Now this has a little bit longer numbers or bigger numbers. So right away before I even start, since I see these numbers are really big, I'm going to try and see if there's anything right off the bat that I can take out. So I see that these are all even numbers. So if I wasn't sure, I could try and divide everything by 2. So I'm going to test that out. I'm going to take out a 2. And then I'm going to say, okay, well, let's see. Do any of these have, in the variables, do they have anything I could take out? Well, we have an r4, r cubed, r squared, and an r. So yeah, all of them have an r, so I could actually take out an r as well. If I took out an r, my greatest common factor would be a 2r. If I took that out, I would be left with 6r cubed plus 5r squared plus negative 18r minus 15. So if you notice, they just rewrote it as a plus and negative, and that's okay. You don't have to do that, but that's what they did. So here, let's go ahead and go from there. We're going to forget about the 2r. We're just going to kind of just leave it out there. What I'm going to focus now is on trying to factor this part. So we have 6r cubed minus 4r squared. Anything that they have in common? Well, right away I see that they have an r squared I could take out. So I would be left with 3 because, oh sorry, no, not 3, 6. I would be left with 6 because 6 times 6r times r squared would give me 6r cubed. And then I put minus, well, r squared times in minus 5 would give me negative 5r squared. So that's what I'm left with here. Now, so that's what they have here. They have r squared times 6r times, oh wait, oh they did it differently. That's okay. Let's go ahead and continue this and see if it works. So now let's do this part. We have negative 18r minus 15. Okay, right away I see here that I could take out a negative 3 from both, and I would be left with 6r minus, no, plus, wait, plus 5? Yeah, plus 5. So then I see here and I see, this is not going to work because I had left with a positive and I left with a negative. So what I'm going to do is I'm going to actually start again. Since that didn't work, I'm going to start from scratch. I had originally combined these two together. That didn't work, so I'm going to try switching that. I'm going to say, okay, well, let's try grouping then 6r cubed and minus 8r. So 6r cubed minus 18r. What do these have in common? Well, they have a 6 in common. They also have an r in common. And I would be left with r squared minus 3. Okay? And now I'm going to go ahead and try grouping these other two. So we're left with 5r squared minus 15. 5r squared minus 15. So right away, see, these have in common a 5. They don't have a variable, so just like that. And we'd be left with r squared minus 3. So now did I end up with in the same thing in parentheses? Yes, so I could go from here now. So now that I have that, I can take out an r squared. So I'm going to take out an r, sorry, I'm going to go ahead and write it down here. We can take out an r squared minus 3, and what's left over? Well, let's circle that. We're left with 6r and a positive 5. So the other one would be 6r plus 5. And we are now done factoring. Now the only thing we need to remember is to go ahead, we had originally factored out a 2r, we need to make sure we add it to the front, and now we have 3 things multiplying actually to give you this original problem. And that's it.